Okay, so we'll go with keys and coupling for machine design. One of the two topics that we will have to finish today. So, keys and coupling. Okay? Keys and coupling. Sir, susi. Susi daw, susi. Couplings. Couple, di ba? Keys, in Tagalog, in machinist's term, this is a kunya. Kung saan ginagamit natin siya as a fastener dun sa ating shaft and then yung connecting sa kanya. Either be it a flange, a cylinder, na kung saan mini-minimize natin yung wear and tear dun sa ating shafting. Okay? Ganyan po, keys and coupling. Now, for couplings naman, yan pong coupling, makikita nyo yan in machines kung saan pwede niyang pag-connect ang two separate shafts that is turning into parallel direction. Okay? Concurrent din. Pwede rin namang transaxle. Ibig sabihin, yung mga axle niya, pinagko-connecta niya. Pwede rin yung coupling. Easy to disconnect and connect. Pwede rin, that is non-concentric na coupling, kung saan pwedeng umikot ang isang shaft. Non-concentric dun sa isang shaft, connected via a coupling, a coupler. Okay? So, keys and coupling. Again, key. A mild steel inserted between the shaft and a hub to connect this together in order to prevent relative motion between them. Ay inserted parallel to the axis of the shaft. So, saan po natin ini-insert to? In a hub and a shaft. Commonly, yung key is mas prone into shear and breakage. Mas malambot po siya dun sa ginagamit nating material dun sa shaft. It also prevents yung easy wear and tear nung shaft tsaka nung hub mo. Kasi mas mahirap gawin yung shaft mo kaysa sa key. Yung key kasi is a piece of metal that is shaped excuse me, rectangularly or circular. Maraming uri ng keys dyan, okay? Pero let us go deep inside dun sa kanyang mismong calculations, okay? Meron tayong mga iba't ibang uri ng keys. Yan, ginagamit nga lang natin siya in order for us to control the breakage ng ating mga machine members. And commonly, ang keys kasi ginagawang locking mechanism ng hub and shaft. And then, saan natin siya ini-insert? So, yung hub and the shaft is made with a keyway, where a keyway is a slot or recess. Recess na kung saan siya yung pinagpapasukan ng key in a shaft and the hub of the pulley to accommodate a key. Kaya nga, key. It fits in a pattern. It fits in a certain shape that is exactly what the shape of the key is. Next, okay, maraming uri ng keys dyan, okay? Meron mga keys na dinivide natin into two parts. Meron niya constant cross-sectional, ibig sabihin, hindi siya nagbabago yung cross-sectional area niya. Okay? Uniform. There are a flat key, a square key, a round key. Ito flat, pag ganun, flat. Ito square, natural. Square yung cross-sectional area, round key is bilog. Okay. Variable naman, wood rough, ibig sabihin papaliit yung kanilang cross-sectional area habang pinapasok mo dun sa recesses ng iyong hub and shaft. The jib head taper key, ibig sabihin taper. Kapag sinabing nagte-taper, it is paliit yung kanyang cross-sectional area. Nag-taper. Saddle, ibig sabihin it sits on a certain shape. The Kennedy or a tangential, a feather key, a roll pin. May mga roll pin, commonly talagang circular sila or cylindrical. Mga roll pin. Pero commonly, ang pinag-uusapan lang natin when it comes to calculation are the flat key, square key, and round key. Kasi easily determinable yung kanilang mga cross-sectional area. Okay? Again, let us recall. Di ba ang stress natin is the ratio of the force that is applied to a certain cross-sectional area of your machine member. Diba? Ganun yung formula natin pagdating ng stress. So dito, mahalagang alam natin kung paano natin gagamitin yung cross-sectional area nung ating keys. Bakit? Diyan kasi natin i-determine if the key is in shear or the key is in compressive stresses. Okay, so let us go with the stresses. Now, first, we talk about the splines. Yung splines, commonly kasi, ang shaft mo, imbes na maglagay ka ng key, ini-embed mo na lang yung shape ng keyway and yung key doon sa shaft mo. Ngayon, makikita nyo yung dulo ng mga transmission shafts. In order to fit into the flywheel, in order for it to fit into the transmission or to the clutch, yung dulo nun may mga ngipin. So, yun yung mga splines na kung saan mag-fit in sila dun sa mga recesses or dun sa mga butas-butas doon. Okay? Pag nag-fit sila, it creates torque. Okay? Where a spline is a key made of integral with the shaft which fits in a keyway broached in a hub. So, the process in machine elements, okay, the term that, it is a term, okay, yung broach is the term or the work na ginagawa mo in order for you to create keyways in a shaft or in a hub. That is broaching. It is a job inside a workshop where you create keyways in a hub or a shop. That is what you call broaching. Brocha sa Tagalog. Ibig sabihin, you force something that is shaped like the key and you cut the machine member in order for you to create a slot. Oh, yung spline mo usually consists of 4, 6, 8, 10 sets of splines. Okay? Now, in order for you to get the power that is transmitted, commonly the general power formula, kukunin mo. That is 2 pi Tn. Okay? Now, Rm. Anong ibig sabihin ng Rm? Kung meron kang Dm as the mean diameter, yung Rm is the mean radius. And you can get that by using this formula. 1/2 nung D plus D. Ano yung malaking D at maliit na D? Yung malaking D is the outside diameter at yung maliit na D is the mean diameter. Or root diameter pala. Yung pinaka-root niya dito. Dito yung outer diameter mo, which is D. Yung diameter na malaki dito, up to the splines. Okay? Plus yan. Divide by 2. Now, we talk about the shearing and compressive stresses of the key. If we are talking about shearing stress for the key, ibig sabihin, your key will break like this one. Okay? Let us project the key like this. If you have a key, like this one, okay, ipaproject mo. If it breaks in the middle, palagay natin, ito yung key natin. Okay. If it breaks in the middle, ibig sabihin yung force that is applied there is what? Parallel to the shearing area or perpendicular to the shearing area? Siyempre, parallel. Okay, to the shearing area. Ibig sabihin, kapag nag-shear yan, ibig sabihin na punit. Napunit siya along the shear area. So, the projected area there, kung makikita nyo, if this is the width, this is the length, this is the height. Ano yung shear area na pinag-uusapan mo dyan? Siyempre, yung area that is being cut into 2. Okay? That is being cut into 2. Okay. Now, if the force applied here, diba, we call that a force that is applied in a certain distance, you call that as the torque or the moment. That is the force multiplied to the distance it is applied. Or simply, where the distance it is applied, nasaan po yan? Okay? Torque is Fr or the moment arm. Distance or the diameter divide by 2. Or simply, Fr. Okay. That is the torque. Now, when we are talking about yung force dito or the shearing stress, diba, that is shear stress, that is force over area. Okay. Yung force mo dito, tignan mo ha. Tignan mo dyan. Makuha mo yung force dyan, dito natin makukuha yung force. Okay? Yung force natin dito is simply torque over R. Okay? Now, the area here is the area that is being sheared. Ano yung area that we sheared here? Di ba length times width? O, tuturuan ko kayo kung paano madaling matandaan siya. Hindi ko na kayo pahihirapan. Wag niyo tong sundan, okay? Tinuturuan ko kayo kung paano siya madi-derive. Okay. Kung na-derive na natin yan, okay? Going here. Huwag yung tignan, ha? We are talking about shear on keys. Now, in order for us to get the shear on the key, simple. Pagsamahin natin to. S is equal to T, the torque, over R, multiplied to the length and the width. Ganun lang kasimple. Okay? Sir, saan po nagmula? Yung 4. Ang problema mo dyan, yung 4. Okay. Tignan nyo dito. Sir, normal ba yun may 4 dyan? Sige nga, tignan nyo kung bakit. May paliwanag dyan kung bakit siya 4. TR, di ba? TR. Mamaya natin papuntahan yung 4 dyan. Bigyan ko muna kayo ng madaling tandaan dito. If that is in shear, okay? Saan ba dito yan? Kalimutan ko tuloy kung paano ko pinaliwanag yan. Now, for keys pala. Ito pala, may nalimutan ako dyan. Now, for keys, tignan mo. The stress on keys will be twice of the torque over the area and then diameter of the shaft. Diameter of the shaft. Torque, diameter of the shaft. Okay. FR, diameter. Saan nagmula yun? FR. Okay. Ayun, ito na pala. Naalala ko na. Okay. Para mas malinaw sa inyo kung paano siya maalala mo. Okay. Diba ang stress? General, that is force over area. Diba? Generally speaking, the torque is the force that you applied on a moment arm, which is your radius kapag dating ng shaft, diba? Moment arm on a shaft. The torque is applied on a single plane. Okay. So, yun. Yung shaft mo, pabilog yan. You applied your force here. There. Okay? That is the force that is applied. Ngayon, at this point, ano yung moment arm mo? Ayan, no? That is radius. Diba? Eh, yung force mo, you call the torque is equal to F times R. Ngayon, dito sa shear, general formula for the shear or the stress is F over A. Ngayon, yung F, i-reform mo dito, F is equal to T over R. Where R is simply, di ba, twice the diameter. Okay? Ay, twice the diameter. Twice of your radius is the diameter. O, the torque over D over 2. Simplify natin to ngayon. Okay? In terms of the force. Okay? Dito papasok yan. Yung force will be the torque over diameter over 2. Divide by the area that is being sheared or compressed. Okay? O, dyan yung general formula. Now, we reform this one as torque over D and then A. Where your D is the diameter of the shaft. Shaft to eh. Ayan o, shaft yan. And, nasaan yung 2? Iakyat mo dito. Now you have the general formula for the stress. Okay? For the stress. Okay? Since, tignan nyo since, yung i-apply mong torque dito, the torque that will be expressed, okay, the torque that will be induced dun sa iyong shaft is the same torque that will be induced in your keys. Okay? Note, torque is constant. from shaft to the keys. Tandaan niyo yan. Okay? Now, talk about this one. Paano ko pinakilala sa inyo? Ito na yung formula niya dapat. Okay? Ngayon, meron na tayong stress dito. Okay? Meron na tayong stress. If we can say that the torque is same dito, then we could say, yung shear stress dito that will be applied or that will be observed in your key is simply equal to, tignan nyo twice of the torque, tapos area, and then diameter of the shaft. Now, what is the area projected here? What is the area of the shear? O, simplify natin. The area of the shear there. Ano yung na-shear dyan? Ano yung na-shear? Yung length and width. So, twice of the torque over length times width times diameter of the shaft. And shaft diameter. So, now my friends, you have the formula for shear. Okay? Ganun lang po kadali yun. Hindi mo alam yung formula, sir. Mahina ka magkabisado. Gawa mo ng kwento. Gawa mo na lang ng kwento. Kaya lang medyo bastos yung kwento dito. Huwag ko nang gawa ng kwento. Ano? Huwag ko nang gawa ng kwento. Panoorin nyo na lang sa YouTube kung paano ko siya binigyan ng mnemonic. Pero tinuro ko sa inyo kung paano siya ma-derive. Okay? The general formula for your stress that will be induced dun sa inyong shaft is equal to 2T over A area multiplied to DS. Ngayon, kung same sila ng torque capacity, makuha mo dito, i-apply mo na lang. But the area there will be the area projected or the area of the shear. O, anong nangyari? Yung area ng shear, ipasok mo dito. Length times width. O, length times width is the area of the shear multiplied to the diameter of the shaft. Now, you have the formula for the stress that is induced to your keys on shear. How about compressive? Okay. Ito naman, compressive naman tayo. Let us go to compressive. O, magdodrawing ulit ako dito. Huwag na natin pansinin to kasi nakakalito to eh. Huwag kayong bumasi sa 40 wild. Okay, 40 hold. Okay? Dito tayo, 2T wild. Dito Yan, ito na lang. 2T. 2T wild. Ayan 2T wild. Yung isa, 40 wild. Hold. 40 hold. Okay? Dito tayo sa compressive naman. Mag-drawing ako. So, for compressive, i-drawing ko ulit. Yan. Pag compressive, parang iniipit yung inyong key. Okay? So, dito, ano ba yung exposed? Kung itong half ng key mo, nakabaon yan dun sa shaft mo, ibig sabihin, ang nalalagyan mo lang ng compressive stress there is the one na nandito sa baba. Okay? Yung key. Ito yung nalalagyan mo ng compressive stress. Nakabaon yan sa slot eh. Ibig sabihin yung force mo is directed there. This is compressive. Ngayon, if this is the width, the height, this is the length. Ngayon, ano yung nakuha lang dun sa height? O di h over 2. Ngayon, balik ulit tayo sa SS equal to 2T over A projected multiplied to the diameter of the shaft. Hindi mo gagalawin yung diameter ng shaft. Ang gagalawin mo dyan is the area projected. O di 2T over AP. Ano yung area projected? O di H over 2 multiplied to the, ano yung nandyan? L. Nandyan is L. Multiplied to the diameter of the shaft. Ngayon, iakyat ko tong 2. O di ang mangyayari, 4T over hold. Okay? That is very basic. Hindi na SS yan, ha? That is now compressive. SC. SC, SC. Ganun lang po mag-mnemonic sa pagdating dito sa keys. Yan lang po yung tatandaan nyo. Wala nang iba. Andiyan na yun. Now, for couplings naman, let us go to couplings. For coupling, for flange couplings, yung mga flange, di ba? Yan yung kinakapitan ng bolts mo. Okay. Ayan. Sir, gagamitin po ba namin itong power transmitted? Actually, hindi na. Gagamitin ko pa ba to? Hindi na. Ano yung binigay ko sa inyong power dyan? For general power, you use this one. Power is Tn over factor. Anong unit ng Tn mo dyan? Ang unit dito kapag SI. SI unit, okay? Control J. SI unit. Anong unit dyan? Yung N, yung T, dapat equal to Newton, millimeter. Yung N, dapat yan RPM. RPM. Tapos yung factor mo, that is 9549123 Newton, millimeter, RPM per kilowatt. Tapos, dito naman, pag English or imperial units, anong unit mo dito sa torque? Dapat dyan naka pound inch. Tapos, yung N is RPM again. Tapos, dito yung F mo is equal to 63025 pound inch RPM per HP. Dapat ganyan, okay? Now, hindi mo na gamitin to. Kahit di na yan, okay na yan. Na dito, paano natin madaling makukuha yung formula na to? Sir, pahirapan ko pa ba sarili ko? Nako, wag dito. Wag itong kunin mo. Wag ito. Wag din ito. Okay? Now, let us go here. Mas gusto ko kasi dinodrawing to eh. Now, we talk about the shear on the bolts. Kapag na-shear yung bolt, di ba naputol? Okay? Kapag naman sa flange, okay? Tignan mo. Dito, mas gusto ko tong drawing nito. Kaysa mag-drawing pala ako. Now, when a force is applied, okay, over an area, tignan muna natin to. Let us look it into a collective manner. So, S is equal to force over area. Now, when we are talking about bolts, syempre dun tayo mag-focus sa area ng bolts, number of the bolts, di ba? Ngayon naman, kapag na pinag-usapan natin yung flange, pag-usapan natin yung flange. But let us first talk about yung bolts. Di ba? Binigay ko isa pang formula dito, 2T over area that is projected or the area of the stress area and multiply mo dun sa diameter nung shaft. Since, ang paliwanag dyan, yung torque sa shaft, yung torque sa flange, yung torque sa bolt, the same throughout. Equal. Okay? Now, what is the area projected when we are talking about the bolt? For bolts. Ano ba yung pinag-uusapan natin sa bolts? Di ba ang bolts, kapag umikot yan, yung mga bolt nakatusok yan dun sa flange mo. Ngayon, kapag umikot po yung flange mo, kasama nung sa shaft mo, nagtitwist yan, di ba? Pag nagtwist, ano mangyayari sa bolt mo? Since nakaganyan siya, nagtitwist siya dun sa isa pang shaft that is non-moving, ibig sabihin, ano na-experience niya? That is shear pa rin. Okay? That is shear pa rin. Ibig sabihin, ang bolt, when in shear, mapuputol yan sa isang section. Yung cross-sectional area ng bolt, may nakita ka bang bolt na square? May nakita ka bang bolt na oblong? Siyempre, hindi, di ba? So, yung area projected mo dito will be the area ng bolt. So, for bolts, in order for you to get the shear on the bolts, 2 or twice of the torque. Laging ganun yun, kaibigan. Lagay mo dyan. Twice of the torque. And then, diameter of the shaft. Lagay mo na dito. Okay? Kaya lang, ang problema mo dito, wag mo nang kunin yung diameter of the shaft. Nasaan ba yung mga bolts mo? Tignan mo naman dito. Ito yung bolt, 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 bolt. Ang daming bolts. Anong circle ang tawag dyan na pinag-iikutan ng bolt mo? Kung saan siya umikot ha, wag mo na kunin yun sa shaft. Kung saan siya umikot. Okay? Kung nasaan yung kanyang rotation. Ang rotation niya is concentric. Okay? Concentric siya dun sa diameter ng bolt circle. Saan may measure yung diameter ng bolt circle? Ito. Ayan o. The bolt circle diameter or diameter of the bolt circle. Ayan, DBC. Okay? DBC. And then, nakuha mo na yung diameter. Ilang bolts ba ang ginamit mo? Hindi pwedeng iisa lang. Hindi pwedeng apat. Yung lahat ng bolts na nandyan. Yan yung makaka-experience po nung shear. So, the number of the bolts. Tapos, ano yung area ng bolt? The shear area of the bolt. That is D. Okay, pi over 4 multiply to diameter ng bolt squared. Okay? Nakuha mo yung area. Diameter nung either the shaft, pare-pareho lang naman yan eh. Sa torque. Saan ba nag-apply ng torque? Mag-a-apply ka ng torque sa bolt circle. O, di bolt circle yan. Now, you have the shearing stress on the bolt. Yun yung kwento dyan. Ha? Hindi nyo kailangan memorize ng formula. All you have to do is to have it in your imagination. Okay? Yun lang po yun. Now, when we are talking about the flange, flange naman. Ano yung pinag-uusapan mo dyan sa flange? Yung flange is ito, yung buo. Tatanggalin mo lang yung, anong tatanggalin mo dyan? Siyempre, yung flange mo, i-project mo yan. Di ba? Yung flange mo is parang palaman yan. Eh. Palaman. Ito yan. It is a donut. Okay? Donut yung flange mo. Pangit ang drawing ko, sorry. Donut yan. Tapos meron yang kapal. Na thickness yan. Kapag project mo, okay, side view, para yung ganyan, di ba? Ganyan yung flange mo, may hub dito sa gitna. May thickness ka dito. Okay? May diameter ka dyan. Okay? Diameter ang tawag dito. Diameter ng flange. Flange. Nandito sa gitna yung bolts. Okay? Ngayon, kung nag-shear dyan sa gitna, doon sa mga butas niya, di ba? Pag ginamit mo yung bearing stress, that is diameter of the bolt, tapos yung thickness ng flange. Yun ang i-consider mo. But let us go back here. Yung stress, di ba equal yan sa twice of the torque over area projected multiplied to the diameter na in-applyan mo ng torque. Ngayon yung torque, nag-apply ka dito sa bolt circle pa rin naman. Okay. The stress on the flange is equal to twice of the torque that is applied. Okay? Divided by, wag muna natin yung area projected. Okay? Diameter of the bolt circle pa rin. Doon ka pa rin naman nagkaroon ng shear eh. Okay, sa flange. Diameter of the bolt circle. I-consider mo ulit yung number of the bolts that is present there. And then, ano yung area projected mo? Di ba may butas yan dito sa gitna? Di ba may butas yan? Yan. Butas yan. Ngayon, sa butas na yan, magkakaroon ka po ng stress. Ano yung area affected by that? Ngayon, yung bilog na yan, cylindrical. Okay? Cylindrical yan, yung butas. So, kukunin mo yung diameter of the bolt and then the thickness of the plate. Then, you can have the stress that is applied on the flange or the stress that is experiencing by the flange. Yun lang po. Ganun lang po kadali mong matatandaan yung formula niyan. Hindi mo po kailangan hindi mo po siya kailangan mag-memorize. All you have to do is to yan. Imagine. Dalawa lang talagang tinatandaan mo dyan. Bawat topic. Lalo na sa keys and flange coupling. Very basic. So, in order for us to understand it more, we have to apply it into different problems. So, let us solve the problems. So, problem number 1. I have problem number 1. So, problem number 1, a 4-inch shaft using a flat K. Flat K yan to. Flat K yan ha. Bisaya lang. Flat K. Flat K. Ayan. Flat K. Whose width is 1 inch. May width ka na 1 inch. Is transmitting a torque of 63,000 inch-pound. Hindi inch-ib. Inch-pound to. If the design shearing stress is 5,000 PSI, the safe length is, we don't know. Dalawang alam natin. Shearing eh. Shearing stress is equal to twice of the torque over, hindi natin alam, area projected times D ng shaft. Ay, ito lang yan. Pinag-uusapan natin dito is shearing. Ibig sabihin, kapag shear, nasa gitna. So, this is twice ng torque over length times width, diameter ng shaft. Ang hinahanap natin dito is the length, safe length. So, we reform the equation. The length of the key is equal to, cross-multiply ko na lang itong dalawa. Okay? Twice of the torque divided by SS WD ng shaft. So, the length of the key there is equal to twice of the torque. The torque is 63,000 inch-pound. Or pound-inch. Divided by SS 5,000 pound per inch squared. You multiply it with the width, which is 1 inch. And yung shaft is 4 inches. So we cancel all the same units in order for us to solve the problem and arrive with 1 unit. Okay, so pound, inch, inch squared. So, isa lang ang natira, inch lang. We can calculate the value for the length of the key. That is 2 times 63,000. Sobra na isang zero. Divide by 5,000 times 4. The answer is 6.3 inches ang kanyang length. Very basic pa yung problem number 1. That is the safe length of the key. Problem number 2. A 1,200 millimeter cast iron pulley is fastened to a 112.5 millimeter shaft by means of a 28.13 millimeter square key. 28.13 millimeter square key. 175 millimeter long. So, square yung kanyang cross-sectional area. What force acting on the pulley rim will shear the key if the stress of the key is 20.67 kg per millimeter square? Now, the assumption here, di ba sinasabi ko, that the assumption is yung torque niya is constant. So, the torque that is experienced by your shaft is equal to the torque that is experienced by your pulley and the torque that is experienced by your key. Now, we can say that yung force that is applied on the key is equal to diameter ng pulley over diameter ng shaft multiplied to force on the pulley. Sir, saan nagmula yan? Okay. Yung torque. Tingnan nyo ito. Di ba ang torque is force times radius? or force multiplied to diameter divide by 2. O, dito, equate lang natin. Very basic yan. So, force on the key. Okay. Force on the shaft multiplied to diameter ng shaft over 2 equal to force on the pulley tapos multiplied to diameter ng pulley over 2 equal to force on the key multiplied to diameter ng key over 2. Etong 2, pwede naman natin cancel lahat yan. Same lang naman yan. Ayan. So, pwede nating sabihin that the force on the key is equal to pwede rin diameter ng shaft na rin to eh. Kinukuha mo naman dito eh. Doon naman na ano eh. Hindi diameter ng key. Wala pala diameter ang key dyan. Diameter of the shaft. Dito ako nagkamali. The force is applied on the diameter. Nandun siya within the diameter yung sa key. Yan. Force on the key equal to diameter ng pulley. Force on pulley. Tapos, diameter of the pulley over diameter ng shaft. Ayun lang. Very basic to. Now, in order for us to solve, ang binigay dito is the stress on the key. Shear stress on the key. So, SS on the key. That is 2 over T. O, length times width times the diameter of the shaft. Ang hinahanap mo dito is the torque muna. Okay, torque. But the torque simply is force times diameter of the shaft over 2. Yan yun. Pwede ba nating palitan yan ng torque? Ayun, pwede. S2. Mali ata ako nung lagay. Over 2. Ayun, 2. Okay. Fixed na. Ayan, 2. So, dito sa key, torque diameter ng shaft, force on key. Ayun. Force on key, dP tapos ds. Saan napunta yung 2? Na-cancel natin yung 2 dito. Maka-cancel mo yung 2 kasi nasa baba. Ayan. Cancel natin to. Cancel natin to. Ayan. So, SS now, yung shear stress is equal to force on key tapos multiply to diameter ng pulley and diameter ng pulley of the diameter ng shaft. Diameter ng pulley over diameter ng shaft. Yan. Umakit lang yung shaft. Divided by length times width. Ang hinahanap natin is the force on the key. Force on the key is equal to SS multiplied to L times W divided by dP over ds. So, the force on the key SS is 20.67 kilogram per millimeter squared multiplied to length. Ano ba yung length na binigay sa dyan? Okay, 175 millimeter long. Mm. Tapos yung square niya on sides is 28.13 mm. Divided by dP over ds. Diameter of the pulley is yun, 12 mm. Tapos, diameter of the shaft, ayun, 112.5 mm. We cancel all the same units. Mm squared, mm squared, mm, mm. So, kilogram force. So, the answer will be for number 2. That is 20.67 times 175 times 28.13 divided by 12 divided by 112.5. The answer is 9539. Force on the key. 9539.37 kilogram force. That is the force on the key. It's for problem number 2. How about problem number 3? A line shaft with a power of 100 kilowatts at a speed of 1,200 RPM had a rectangular key used in its pulley connection. Consider the shearing stress of the shaft to be 40 MPa and the key to be 200 MPa. Determine the width of the rectangular key if it is 1/4 of the shaft diameter. So, ibig sabihin, yung width daw dyan, yung width nung iyong key is equal to 1/4 ng diameter of the shaft. Now, you have two problems here. You have two missing here. So first, gamitin mo yung sa shearing stress ng shaft in order for you to get the diameter of the shaft. Okay. Very basic yon. Now for the power, in order for you to get the torque. Kasi hindi mo kuha yung shaft diameter kung wala yung torque. Let us recall. Okay? Yung shear stress on your shaft is equal to 16T over pi d cube. Tama ba? Check. Okay? And then yung shearing stress on your key is equal to ano nga to? 2T over WLD ng S. Now, hanapin muna natin yung torque dito or yung diameter dito. Yung diameter. Saan po ba natin makukuha yung torque dito? Gamitin mo tong power. So, power is equal to Tn over factor. Ang problema, this is in SI units. Pwede ko ipasok to dito, okay, sa torque. So, in order for you to get the diameter, d cube is equal to 16T over pi ng SS. O yan, ginagamit ko na naman yung algebra dito ha. Very basic to. So, 16. Yung torque, dito mo kuha. So, equal yan sa power multiplied to factor divided by n multiplied to pi multiplied to SS. And then, kunin mo yung cube root. Kunin mo yung cube root para makuha mo yung diameter. Okay, solve na. Makuha ko na yung diameter, okay? The diameter of the shaft there is equal to yung cube root nung buong expression. So, 16 multiplied to the power of 100 kilowatts multiplied to the factor 9549.123 Newton millimeter RPM per kilowatt divided by ilang RPM ang meron dyan? 1,200 RPM. Very basic na algebra to. Pi. And then the shearing stress there for the shaft is 40 MPa. 40 Newton per millimeter squared. So, matitira dito millimeter cube. Kaya akit yung millimeter dyan. Cancel mo sa kilowatt, cancel sa kilowatt, RPM, RPM, si Newton and si Newton. Ang matitira, tatlo. Cube. So, cube root, kunin mo. Very basic ang calculation kapag magaling kang mag-algebra. So, 16 times 100 times 9, 5, 4, 9, 1, 2, 3, divide by 1, 2, 1,200, shift pi times 40. So, the shaft diameter is 46.62. 46.62 mm. No, nagbigay dyan ng ano, ibigay ng condition. Hinahanap natin is the width of the rectangular tip. Pwede rin natin hanapin yung kanyang length. Okay? Hinahanap ko ba yung length dyan? So, okay. Hanapin natin yung width muna. So, the width is equal to, dapat dito ang hinahanap sa problem na to yung length para dadaan pa muna sa width. So, width of the key is equal to 1/4 ng diameter ng shaft. Now, binigay sa'yo yung shearing stress ng key. In-extend ko yung problem hinahanap ko na yung length ng key. Para maging challenging is equal to 2T over WL ds. Okay, reform natin. So, 2T over WL. Ang problema mo, yung diameter ng shaft is given na there. Yung W is hindi pa. So, burahin natin yung W. Okay? W is 1/4 nung ds. O di 1 over 4 ng diameter ng shaft multiply to diameter ng shaft multiply to the length of the key. Makukuha mo ngayon yung length of key. Okay, cross-multiply ko sila. Now, the length of the key there is equal to 2 twice of the torque divided by 1/4. 1 over 4 nung ds squared multiplied to the stress nung sa key. Very basic. So, twice of the torque, twice. Yung torque na binigay dyan is, wala kang kinuhan torque. O nga pala, wala kang kinuhan torque. Dito pa rin, kunin ko pa rin dito. Yung torque niya is excuse me, power factor over N. Ayan di ba? Yung torque, kung ako tong torque. Yung torque is equal to, from here torque is equal to power factor divide by N. Para hindi ka na paulit-ulit. Very basic lang yan. Power multiplied to factor over N divide by 1 over 4 diameter ng shaft squared tapos SS ng key. Yung sa key, mas mataas talaga yung stress nun. So, 2 times power 100 kilowatts sobra na isang zero multiply to the factor 9,549,123 Newton millimeter RPM over kilowatt. Ganito talaga ako mag-solve. Hindi ko inuulit-ulit pero ano na lang, ina-algebra ko siya. Tapos yung N is 1,200 RPM multiplied to 1 over 4. Diameter of the shaft is 46.62 millimeter. Square natin yung value. And then the key shear. So, I think that is 200 or 220. 200 MPa. 200 Newton per millimeter squared. Now, dapat millimeter lang po matitira dito. So, kilowatt, kilowatt, Newton, Newton, RPM, RPM, millimeter squared, millimeter squared. So, ang natira is mm. Now, we can solve for the length of the key. In-extend ko lang talaga yung problem. 2 times 100 times 9,549,49. 123 divide by 1 to 1,200 times 0.25 kasi 1/4 times 46.62 squared yung value times 200. Now, the length of the key is 14. 14 ba? May mali ba ako dyan? Diameter of the shaft is squared. 100 kilowatts. 2. nagkamali ako. Length of the key, dapat mahaba yan. Ayun, tama. Tama siya. Tama pala. 14.645 mm. Length of the key. How about yung width ng key? Width of the key is 46.62 divided by 4. Nasa 10, 11. 11.66 mm. Very basic po. For problem number 3. Next one. Ang ratsyada na to. Another problem. A solid steel machine shaft with a safe shearing stress of 7,000 psi. Ito yung sa shaft transmits a torque of 10,500 inch-pound. A square key is used, square na yan, whose width is equal to 1/4 of the shaft diameter. So, width ng key is equal to 1/4 of the diameter ng shaft. And whose length is equal to 1.5 times. So, 1.5 times nung shaft diameter. Find the key dimensions. Find the key dimensions and meron pang kaduktong yan. Yung S, compressive, and shearing stress on the key. Let me take a pause. Okay, so continuation. Ang hinahanap dito is 4. So, the width of the key, the length of the key, compressive stress, and the shearing stress. Okay. Dadaan ka muna dito dun sa stress ng dadaan ka muna sa stress ng shaft, which is ibang stress ng shaft, shear stress of the shaft, 16 T over pi d cube. Yan, dito ka dadaan. Binigay yung torque capacity where yung torque niyan is constant from the shaft to the key. All we gotta do is hanapin natin yung diameter ng shaft. Kasi yung diameter ng shaft, nakadepende dyan yung width ng key at yung length ng key. Now, for the diameter of the shaft, that is cube root nung 16 T over pi nung SS. Okay? So, that is equal to DS. Cube root 16, the torque is 10,500 kung di ako nagkakamali. Inch-pound. Check natin. Inch-pound or pound-inch. Divided by pi. Divided by SS pa yan. Pi multiplied to SS. 7,000 PSI. Pound per inch squared. Bali magiging inch cube yan pag na-cancel. So, diameter of the shaft is 16 times 10,500 tapos 7,000 pi. The answer will be diameter of the shaft is 4 na decimals dapat. 1.9695 inches. That is the diameter of the shaft. Now, the length of the key, tsaka yung tawag dito. Length of the key is, now, masolve na natin yung width ng key. 1/4 diameter ng shaft. 1.9695. So, width of the key is, divide ko na lang ito ng 4. 1.9695 divide by 4. Yan. So, that is approximately 0.4924 inches. Width of the key. Now, the length of the key. 1.5 times of the diameter of the shaft. 1.9695. 1.5 times 1.9695. Yun. That will be 2.9543 inch. Solve na natin. Yan. Hanapin na natin si compressive muna. That is 2T. Ang gamit mo dito is H over 2 times length times diameter of the shaft. So, twice of the torque, 10,500. Same lang naman yan. Pound-inch. Divide by H over 2. Ano yung H mo? May binigay ba ditong H? Walang height na binigay. Square key pala. So, yung width niya equal din sa width of the key is equal to H ng key. Okay. So, this is divide by 2. Yung value. That is 0.4924 inch. Yung length, 2.9543 inch. Tapos, diameter of the shaft is 1.9695 inch. So, ang lalabas dyan is pound per inch squared. SC is PSI. Okay. So, 2 times 10,500. Tapos, 0.4924 divide by 2 times 2.9543 times 1.9695. The answer for compressive stress is mas malaki. 14659.55 PSI. How about the shear? That is 2T over WL ds. Okay. Multiply natin. 2 times 10,500 pound inch. Yung W, that is 0.4924 inch. Multiplied to the length, 2.9543 inch. Tapos 1.9695 inch. Ang lalabas dyan is in PSI ulit. So, the shear stress is, divide ko na lang to ng 2 kasi may 2 dito eh. Divide ko na lang ng 2. The answer will be 7,329.78 PSI. Okay. Very basic lang po talaga ang keys. Paikot-ikot lang. Yun lang naman yung mga paraan kung paano siya sinosolve. Sometimes, ginagawa siyang yung kanyang sizes, ginagawang ratio to the diameter of the shaft. And sometimes, kinukuha yung torque niya gamit yung shaft, gamit sa power ng shaft. Okay, ganun lang umiikot yun. So, those are board exam problems. And 4 more for flange and couplings. Tuloy natin. Okay. This is the problem. 2 shafts are connected by a flange coupling. The coupling is secured by 6 bolts. The number of the bolts there is 6. 20 millimeter in diameter. So, diameter of the bolt is 20 millimeters. And the pitch circle diameter, ibig sabihin, bolt circle diameter. That is 150 mm. If torque is 120 Newton meter is applied, find the shear stress on the bolts. SS on bolts. Okay. Paano ko nga ulit pinangalanan yon? Di ba? Force over area. Okay. Or that is equal to twice of the torque over area projected or area of the shear or the pressure, area of the pressure, AP, multiplied to the diameter na meron dyan. Okay. Hinahanap dyan is shear stress on the bolts. Shear stress, ibig sabihin each bolt. Okay. So, this is twice of the torque divided by number of bolts. Ilang area, ilang bolts yon yung magkakaroon ng shearing area. So, pi over 4 multiplied to diameter of the bolt squared multiplied to diameter ng bolt circle. Yan na po. So, SS on the bolt equal to 2T, twice of the torque. 2. Ano yung torque dyan? 120 Newton meter. Kaya lang, multiply ko na kagad to. 1,000 millimeter. 1 meter. Number of the bolts, 6 bolts ang meron ka dyan. Tapos yung area nila, pi over 4 multiplied to diameter of the bolt. Binigay ba dyan? 20 mm. Squared. Then multiply mo sa bolt circle na 150 mm. What will be the answer? Cancel natin yung same units. Meter, meter, millimeter, millimeter. Ang natira is Newton per millimeter squared. So, the answer will be 2 times 120 times 1,000 divided by 6 times shift pi over 4 times 20 squared times 150. Newton per millimeter squared is MPa. So, the answer there will be 0.8488, approximately 0.85 MPa. Problem number 1 for flange and couplings. Very basic po yan. How about problem number 2? A flange coupling has an outside diameter of 200 millimeters and connects two 40 millimeter shafts. There are 4 16 millimeter bolts. So, the number of the bolts is equal to 16. And the bolt circle is 140 mm. Number of bolts 4. Diameter ng bolt is 16. And the flange thickness of the plate is equal to 20 mm. If the torsional stress in the shaft is not to exceed 20 MPa, determine the shear stress in the bolts. So, bolts tayo sa flange coupling. If uniformly distributed. Okay? So, again, sa shaft, that is 16 T over pi d cube. Ngayon sa bolt, that is 2T over number of the bolts times sa area nung shear sa bolts, pi over 4 bolt squared tapos d bolt diameter, bolt circle diameter. Ngayon, ang problema natin dito, wala tayong torque. Kukunin natin dito yung torque. Okay? So, i-reform natin. Okay. Yung torque dyan is simply T equal to SS multiplied to pi d cube over diameter ng shaft to diameter of the shaft cube divide by 16. Pwede natin tong ipasok dito ngayon. Okay? So, SS nun sa bolt. Okay? Torsional stress on the shaft. Okay. SS on the bolt is 2 multiplied to SS nung sa shaft multiplied to pi d cube over 16. Pinasok ko na para isang solving. Number of the bolt multiplied to area that is on shear dun sa bolt. Pi over 4 dB ng bolt squared multiplied to diameter of the bolt circle. Binigay yung thickness ng plate, hindi mo na gagamitin yun. Okay? So, isolve ko na siya. So, SS sa bolt is equal to twice nung sa shaft, 26 MPa, that is 26 Newton per millimeter squared. Tapos pi, in diameter of the shaft is 40 millimeter cube divided by 16, wag mong kalimutan, multiplied number of volts 4, tapos area that is projected or on shear, that is pi over 4 times bolt diameter is 16 millimeter, square ko ito, and then multiply to bolt circle na 140 mm. So cancel natin yung same units. So, Newton, dito na lang millimeter cube, dito, millimeter squared, millimeter. Yun ang tira, millimeter, Newton per millimeter squared, or MPa na yan. So, we calculate the value. 2 times 26 times shift pi times 40 cube divided by 16 times 4 times shift pi over 4 times 16 squared times 140. The answer will be 5.836. Okay. Very basic again yung problem. So that is 5.8036 MPa. Very basic. So, kayo na lang mag-solve nun sa flange. Hinahanap ba din sa flange? Shear stress on the bolts lang eh. Okay. Problem number 3. Two short shafts having identical diameters of 38.1 mm rotating at 400 RPM are connected by a flange coupling having 4 bolts with a 100 mm bolt circle. The design shearing stress for the bolt is 12 Newton per millimeter squared. And the design compressive stress on the flange is 15 Newton per millimeter squared. How thick should the flange be? Ngayon, saan natin kukunin yung torque? Sige nga. Kunin natin yung torque gamit dun sa power. Two short shafts. Pero dito, kailangan gamitin natin yung formula natin, yung power over factor. Yung power equal to Tn over factor para mahanap natin yung torque. Okay? Torque will be equal to power multiplied to factor over N. Yan. So, saan natin kukunin ngayon yun? Hanapin natin yung sa diameter ng bolt. Pwede na natin gamitin yung sa shear on the bolt. The shear on the bolt is equal to 2 torque over number of the bolts, area of the shear dun sa bolt, tapos diameter ng bolt circle. Makukuha na natin yung thickness ng flange. Hanapin muna natin yung diameter ng bolt. Walang binigay dyan na diameter ng bolt eh. So, kunin natin yung diameter ng bolt dito. Ito ang nawawala. Yan. Tapos yung torque, hanapin natin. What will be the torque? Two short shafts. So, power. Anong rating nila? May rating ba sila dyan? May power bang binigay? 400 RPM. Short shaft pala, short shafts. Okay? 2 short shafts. Pwede to. Paano gagamitin natin? Ito ba? No. Gamitin natin yung PSME formula. For short shafts. Ano ba yon? Meron tayong line shaft, ano nga, main power transmitting shaft, short line shaft, tsaka short shaft. So sa short shaft, power is equal to N D cube over 38.3. 38.3 ba? Hindi, 38 lang. 53.5 pala yung isa. 38 lang yan. Yung isa, 80. Yung isa, 53.5. Yung isa, 80. 38. Tama yan. So, dito, the power. Okay? Hanapin mo natin si power. Okay? The power on the short shafts, bago natin alamin yung torque. Okay? Dito kasi natin papatong yan. Okay? Hanapin mo natin si power. So, power is N. Anong binigay dyan? 400 RPM. Huwag natin lagyan ng unit. HP naman labas yan eh. 400. Dito dapat naka-inch to. And ang binigay sa'yo dito is, binigay sa'yo dyan, no? Mm. O divide mo na ng 25.4. Diba? Para maging inch. 38.1 over 25.4. I-cube mo. Divide mo ng 38. Ang lalabas dyan, HP. In HP. Ano yan? 400 times 38.1 divide by 25.4. Tapos i-cube natin. Divide by 38. The answer is ito. Okay? Store natin yung value niya kay E. Ayan. The power is 35.5263 HP. Naka-HP to ha. Gagawin ko na lang kilowatt dito. So, the torque, pasok ko na dito. SS ni volt is equal to 2 multiplied to power factor divide by N multiplied to number of volt tapos pi over 4 diameter ng bolt squared. Diameter ng bolt circle. Kaya lang, ang kailangan ko dito, diameter of the bolt. Diameter of the bolt is equal to, square root ko na. Naka-square siya dito eh. Twice nung power, tapos factor. Gusto ko yung mga ganito, para isang pindutan na lang. N, number of the bolt, pi over 4, tapos diameter ng bolt circle, multiplied to SS ng bolt. Yan. Diameter of the bolt is equal to, meron natin lahat. Ayan na pala. Para isahan na lang. 2 nung power, ang binigay sa dyan HP. That is 35.5263. 35.5263. Kaya lang gusto ko dito i-convert ko na kagad. Divide ko na lang ng multiply ko na lang ng 0.746 kilowatt na to per HP. Dito may HP rin. And then yung factor niya, 9549123 Newton millimeter RPM per kilowatt. Tapos, divide ko ng N, 400 RPM, kung di ako nagkakamali. Tapos, number of bolts. Ilan ang binigay sa'yo dyan? 4 bolts. Tapos, pi over 4. Diameter ng bolt circle, 100 mm. And then, meron ka dyang SS of the bolt. For the bolt lang 12 Newton per millimeter squared. 12 Newton per millimeter squared. Isang input sa calcu, tapos to. Makuha mo kagad yung diameter ng bolt circle. Haba, no? So, 2 times 35.5263 times 0.746 kilowatt per HP times 9549123 divide by 400 times 4 times shift pi over 4. Pwede nang i-cancel na agad yan para maging pi na lang. Times 100 times 12. The answer will be squared yan Diameter ng bolt is in mm. Yung HP cancel mo. HP, kilowatt, kilowatt, Newton. Okay, Newton. Millimeter squared, millimeter. Ayun, matitira millimeter pala. RPM. RPM. Diameter of the bolt squared. Okay. Meron pa ako nakalimutan dito. So, nagkakamali. Number of bolts. 4. DBC. SS ng bolt. Newton per millimeter squared. Okay. Twice. Tama ba yung ano? Yun, tama siya. Tama. Millimeter ang matitira. Millimeter squared. Okay. Diameter of the bolt. Newton. Millimeter squared. Millimeter. Okay, tama nga. Yun na yung torque Ang matitira will be 18.3203 millimeters. That is the bolt diameter. How about the thickness of the flange? Coming from here. So, SS ng flange is equal to twice ng torque over the number of the bolt multiplied to diameter ng bolt circle tapos multiply mo dun sa area nung shear dun sa flange. So, that is yung diameter ng bolt multiplied to the thickness of the flange. Ang hinanap natin dito is thickness of the flange. Reform natin. Thickness of the flange is equal to yung torque makukuha to dun sa saan? Diba yung power times factor over N. Yan. So, twice nung power multiplied to factor divided by N, NB, multiplied to diameter ng bolt circle, divided by DB, multiplied to SS ng flange. Okay? So, makuha natin yung thickness ng flange. Twice nung power, that is 35.5263. 35.5263 HP multiplied to 0.746 kilowatt in every HP multiplied to factor 9549123 Newton millimeter RPM per kilowatt divided by N, 400 RPM. Tapos, number of bolts, 4. Diameter bolt circle, I think that is diameter of the bolt circle, 100 millimeter. Tapos, diameter ng bolt is, nakuha natin, 18.3203 mm. Tapos, meron pa ba? SS ng flange, that is 15 Newton per millimeter. Ang lalabas dito is isang unit lang. Okay, millimeter squared. Matitira yun. 100. Ayan. So, RPM, HP, kilowatt, Newton, RPM. Okay. Nasa baba. The answer for the thickness of the flange is twice ng 35.5263 times 0.746 times 9549 123 divide by 400 times 4 times 400 na 100 lang pala times 18.3203 times 15. Okay, the answer for the thickness of the flange will be 11.5115 mm. Okay, na-solve natin yung second to the last problem. This one. Okay, so solve ko na rin pala yan. So, ulitin ko na lang para sa inyo. Basic na yan. Basic na sa atin yan. So, this is the problem. A flange coupling is to be designed using a 25 millimeter diameter bolt. So, meron kang 25 millimeter diameter bolt at a distance of 150 millimeters from the center of the shaft. Ibig sabihin, this is a radius. Radius ng bolt circle. Allowable shearing stress on the bolt is 103 MPa. If the shaft is to transmit 58,000 HP at a speed of 1 to RPM, how many bolts are needed in the connection? So, shearing lang to. Okay? Hanapin mo muna sa power factor. So, you are given a power, meron kang torque, yung speed, and then factor. Diretso ko na to, okay? So, the shear on the bolt is equal to twice ng torque over number of bolt, the area of the bolt that will be sheared, diameter of the bolt squared, tapos diameter ng bolt circle. Kaya lang ang binigay sa'yo dito, 152 from the center. That is, okay? That is, my friends, radius ang binigay sa'yo dyan. Okay? Hindi po diameter ng bolt yan. So, paano natin masolve? Pasok ko na dito. Ang hinahanap natin dito is the number of the bolts. So, reform ko, cross multiply. So, number of bolt will be equal to buo. Twice of the torque, SS ng bolt, tapos yung area of shear, tapos dB squared, and then dBc. Solve na natin. Kunin na lang natin to dito sa power, yung torque. Pwede pa natin yan. Okay? Natin solve. Number of volts. Divide. Yung torque. Diba? 2. Multiply mo ng power. Factor. Kasanayan yung ganito pag-solve ko para dire-diretso. In. Multiply 2. SS ng volt. Multiply 2. Area of shear. Pi over 4. Bolt. Diameter. Squared. Tapos, bolt circle. Very basic. So, makukuha mo na yung number of volts. Will be equal to 2 times yung power na binigay sa'yo dyan. HP. O di gawin na lang natin. Siya lang naman nag-iisang SI, English unit dyan. Gawin nating SI. 5,800 HP times 0.746 kilowatt in every horsepower. Multiply by factor 9549123 Newton millimeter RPM per HP tuloy, kilowatt. Saan ang N? Ilan ba yung speed niya dyan na nilagay? That is 1, 2 RPM. Tapos yung SS ng volt, ano yung allowable dyan? That is 103 Newton per millimeter squared. Tapos pi over 4. Diameter of the bolt is 25 millimeter squared. Tapos, yung bolt circle, that is twice dapat. Twice para maging diameter. 2 times 152 mm. Okay. Dapat ang lalabas dito is walang unit. HP, kilowatt, Newton, millimeter squared. Dito, millimeter squared, millimeter, RPM. Walang unit na lumabas. So, 2 times 5,800 times 0.746 times 9549. 1, 2, 3. 1,200. Sa baba yan. 1,200 times 103 times shift pi over 4 times 25 squared times 2 times 152. So, the number of volts you need there is 4.48. Ngayon, pag sumobra ka parati ng 1, okay, may decimal point. Sumobra na siya, di ba? Ibig sabihin, the number of volts needed there will be 4.48. Approximately 5 volts. Ganyan po mag-design. Okay? So, sobrahan mo. Kapag sumobra siya sa whole number, sobrahan mo na yon. Kahit 0.0001, gawin mo ng 5 yun. Okay? And that wraps up the discussion for flange bolt and couplings. Let us continue our discussion when we meet again next meeting. Okay? That will be all for this topic. Have a nice day.